Hey, folks that are still coming in, if you see anybody standing around outside, if you could flag them down and let them know we're about to get started. Just don't want anyone to miss out. So if anyone's still hanging out in the lobby, let them know, and we'll get started in just a second.
Where were you working?
No, no, I was in education. Oh yeah.
See how this sounded?
No, I listened to more.
Yeah, all right. Hey, we're going to get started. I just want to welcome everyone to the Netflix Kabuki Theater in Los Gatos. We're happy that we could host the Go Silicon Valley meetup this evening. So we have 3 talks lined up for you today, and there's food and drinks, so when we're finished here, feel free to grab some more and finish them off if you'd be so kind. So I'm going to head over to Ati so she can provide some announcements about the meetup and get us started tonight.
So hi everyone. Thank you Netflix for hosting us. Oh, there's light in my face. I'll go on this way. Yeah. So just wanted to talk about this meetup. So the next meetup that we have is going to be at an AI startup in Palo Alto. Liftoff has offered to host. So it's really great to see companies coming forward and sponsoring space. This isn't something that I reached out to them. They reached out to me. So it's great to see the South Bay community growing. I'm pretty excited about that. And also Go 112 is getting released this month, February. So we will talk about that in that meetup. So we will have a Go 112 release talk, and we will have a talk from the AI startup, and also another talk from Fetch Robotics, a robotics company in South Bay that's using Go. But for March, I don't have a company and I don't have talks. So please, asking the community, if your company is writing in Go, please, ask them to host, or if you have a talk in mind, please submit. We can always host at Coding Dojo or, some other place, or at Google. Tim is here, so I'm looking at Tim. Yeah, we can always find a host company, so that would be great. The other series of talks that I host are Women Who Go Silicon Valley. I also run that meetup. And those talks are, and you're welcome to come to that too. It's, it's not specific to, it's not like we, block people based on gender or anything. You can come to those. And those talks are focused on themes. So we pick a topic, like for example, the last topic was networking in Go. So we covered, how the GoNet poll works. And we had Filippo, who works in the Go team, join remotely to answer questions. And it was really fun for us to learn interactively about the implementation. And so the next Women Who Go meetup is also someone offered. So that is Rakuten. It's a publishing company. They offered to host that meetup. And we're going to talk about Raft consensus protocol at that meetup. So please sign up on the meetup pages and, ask your companies to host or sign up to give talks. And thank you so much for coming today. And without further ado, I'll hand it over to Noah, who's going to give us a great talk on APIs. Woo!
Me okay in the background? All right, I hear myself. Great. So hi, my name is Noah Dietz, or No_D_here. No D here on Twitter. Please tweet at me, take pictures of me, and tweet it, and I'll retweet you.
What's the D stand for?
Sorry?
What's the D stand for?
My last name, Dietz. No Dietz. No Dietz here. Hey. Yeah. So today I'm going to give you a talk. Oh, I work at Google. I work on API client libraries and code generators for those at Google. And I'm going to give you a talk today about generating intuitive CLIs for gRPC APIs. Yeah. So what we're going to talk about is we give some context and about the problem, the state of the art, the current state of the art for solving this problem, some more context about how we got interested in it, and then our solution to it, generating command line interfaces, as well as the goals, non-goals, kind of what's in it, and then we'll do a demo. And hopefully, demo gods will be shining upon me. So I like to go to meetups, as you can see. I like coming here with you guys. And last November, so the last meetup of 2018, at GoSV, Go Silicon Valley, we heard from PayPal about their adoption of gRPC and how much they loved it, all the generated code, and how cool it was. And so they were generating in other languages as well, but because it's a Go meetup, they were profiting with their Gophers. Now, like others, they expressed friction to using some of these APIs, some of the gRPC APIs from the command line, where a lot of developers are working. So without a web interface, you've got to write some snippet of code that has a protocol buffer representation that's compiled, and then you have to invoke it like a script or something on your command line. Because these APIs are meant for, they're optimized for machine-to-machine communication. And this problem is already being addressed with the use of a feature called server reflection. It's a gRPC feature. And basically what server reflection means is a gRPC server makes its schema discoverable over the wire so that clients can, without a compiled representation of the schema, can invoke it and traverse the schema, learn what it exposes. So such tools look closer to the popular HTTP curl, as with this example on the side here of gRPC curl, which is a fantastic tool. And as you can see on the side here, gRPC curl enables users from the command line to probe an API, learn its schema, what services, what methods on those services, and what messages, the payloads that those methods require, before ultimately invoking it at the bottom. Looks a lot like curl on the command line, right? Towards the end there. And this tool and many others are great. gRPC curl was featured at GopherCon last year, and it's really cool. But I'd argue that they focus on flexibility. They're really useful in a pinch. If you want to try something out really quickly, just try out a new API. They focus on flexibility as a primary goal and being able to service any gRPC API. So I think the API consumption experience on the command line here kind of suffers. To me, this experience feels more like a step down the assimilation process. We're joining Borg, speaking the language of the APIs of the machines rather than through a human-oriented interface. And building a CLI specific to the API, like by hand, provides that human-oriented interface, and it's done very commonly. Even HTTP JSON APIs that we know about that have curl as well end up with a tailored CLI that make the API consumption experience better from the command line. Google's done it with gCloud, which services both gRPC and HTTP REST APIs, and the very popular kubectl of Kubernetes does this as well. A fun fact I learned from my manager, Tim, is that kubectl actually uses an open API specification to dynamically generate its command structure and do like validation of payloads at runtime, which is a pretty interesting approach to command line interfaces, which was an inspiration of a little bit of the work that we're going to talk about. So our team, the team that I work on at Google, me and Tim, we generate client libraries, among other things, with the primary goal of making API consumption more delightful. And to help people understand our work, we created a course around a sample API called the Kiosk API. The sample API needed a CLI because, like PayPal, we wanted to manually invoke it from the command line and test it out and change things while we were showing people how it worked. And then this CLI was written by hand, and after writing it, we looked at the code and said this was pretty repetitive. We did a lot of the same, network setup and everything, and then just kind of taking the command line invocation and mapping them into message payloads. And then my manager asked the million-dollar question of, why wasn't this CLI just generated? We generate client libraries that are really good. Why can't we also generate command line applications? And so I work on specifically the Go client library generators for some of the Google APIs. And we came up with this project of generated command line interfaces, or GCLIs for short. It's a long name. So the main goal of generating CLIs included generating a human-oriented interface for the command line, something that was really easy to use, made sense to a developer, and represented things well. Going into generating a CLI tailored to a given gRPC API with the protocol buffers. We have the schema of the API. We should be able to represent the entire thing in an intuitive, easy-to-use way. And in the spirit of our team's mission, we want to generate clean idiomatic code that could be used as client reference implementations. So now the non-goals here, just to make sure everyone's clear, we were not trying to build a single tool that could call any generically call any gRPC API. That's what gRPC curl is for, and it does a great job of doing that. We're not trying to replace that. And also, we're not trying to replace the popular gCloud SDK as the canonical CLI for Google Cloud. We will generate, I'll show you later, a CLI for a Google API, but not trying to replace it, just an example. So what are generated command line interfaces, or GCLIs? So GCLIs are a generated Go application that use a popular CLI framework I'm sure many of you have heard about. It's called Cobra, written by Steve Francia, otherwise known as SPF13 on GitHub and on Twitter and everywhere on the internet. GCLIs follow the Cobra design pattern for code and command structure, which was like super helpful when we were designing what the actual output would look like of the generated code. It really helps with extensibility if someone wants to generate a command line, then add their own commands and change things up. And as well as readability, like looking at the project, it's pretty clear where you need to make changes if things are broken. Kind of a self-plug, but we use the Google generated API client libraries that our team writes code generators for. So these GAPICs is what we call them, they use the generated gRPC stubs that you get from having a gRPC API, but they added another layer of abstraction on there that has the kind of API design principles baked into them that Google uses to make the client experience more intuitive and more delightful and easier to use, making things like long-running operations, pagination, authorization, all that stuff a lot easier to use. So the generated CLIs use the GAPICs as well. And you can generate GAPICs for non-Google APIs as well. They totally work on that. And if you're interested, if you go to GitHub, Google APIs is the organization, has all of our generators in it. GAPIC Generator Go is the one that contains both our client library generator and the CLI generator. So diving a little bit deeper into the goals, now that we know what a GCLI is we want to generate a tailored API command line experience. So to me, that meant supplying an intuitive command and argument structure that was hard to mess up for a developer on the command line, for a user on the command line. And if you're familiar with protocol buffers, in the API, you have a service. It's just like a library or a kiosk service. And in that service, the services are the first level of the subcommands. So you have a root command like kubectl. The next command would be the service name. So for example, I'll use kiosk signs, the sign service. And that's the first level of subcommands. Second level of subcommands is the RPCs, the actual methods on that service. And then finally, the actual input is the message field, the fields of the message payload flattened out into command line flags so that you're not providing some arbitrary JSON string on the command line, fat fingering everything, messing it up. I do that all the time. This way, you have the flags, you have that are validated and easy to understand and use. So this approach can be and typically is applied to CLIs for HTTP, JSON, REST APIs with the HTTP methods like put or create, get, those types of things, serving as the first level of subcommand, followed by the resources that you want to use and the request payload flattened out as command line flags as well. So it's not anything new, but that's the RPC, the protocol buffer version of it. And to help the first point, or the first point also helps with the second point in that structuring it this way helps someone learn the API. It makes it a lot easier to navigate it, and once you learn one command, it's pretty easy to figure out what the next command you want to call would be. And structuring the CLI to mirror the client library and in turn the API schema educates the user while they're consuming it. I could then take this command I type in on the command line, and I know exactly what the code should be in the client library because I know which service I'm calling, what method I'm calling on that service, and what the payload should be. So that's transferable knowledge from the command line all the way through to your program. And in addition to that, having help commands auto-generated from Cobra really helped. Taking the comments, the documentation from the protos, the API schema itself, and putting them in as the documentation for the commands was really helpful, and it makes it easier for people to understand. And then the automatic bash completion generation from Cobra is super useful because I don't know how much time it saved you guys on the command line, but for me, it saved a lot of time just tabbing through everything and type one letter, tab, 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 just tab banging the whole time. See what I have, right? So you get auto completion of the services because that's the first level of subcommands. You get auto completion of the methods on the service. This is the next level of subcommands. You also get auto completion of the flags on the command line. So you can show what all of the fields are that you need to provide on the command line if you don't want to use the help documentation. So another goal we have is having the GCLI, the generated CLIs be good client reference implementations. And so the code, ideally, you should be able to just kind of copy it and drop it into another application, like the call site and the message building and everything. So this meant we needed to generate clean, well-structured Go code so that developers could easily read it and understand it. And I just followed the structure typical of a Cobra application. Each command is broken out into its own file with the same kind of structure to it. This was really helpful in guiding how everything was templated and what the input should look like. It also meant that the variable and command names had to make sense. You couldn't just say A or B or whatever. In this example, we have an input message for creating a kiosk is a create kiosk request. And so the corresponding variable that contains that payload is a create kiosk input of that type. And you can imagine the fields for that are accessed from that object in the same way and represented in a similar way as a flag. And also, the method create kiosk ends up being a create kiosk command. And on the command line, that looks like, for example, K kiosk service create kiosk method. So it's pretty predictable how everything relates. And then I could understand where I needed to make a change if I wanted to extend a command, or if I wanted to even just go and take the code and copy it into another application. And then finally, I wanted to make it easy to grasp things like streaming and LRO, pagination, the more involved API principles that we have. And so Go really helped with that. Things like Go routines for processing multiple streams at once. And then the GAPX themselves, the client libraries you generate, have good ways of portraying communicating these ideas. And so it was important that we communicate those in the right way such that copy paste the code. We're all lazy and we like copy pasting stuff. So okay, with that, I'm going to generate a CLI for the Cloud Natural Language API. I'm going to call it, and then we'll poke around the command line interface and see what it has. So I'm going to do a couple of things. Go. All right. I just copy some stuff. I got to make sure I got my token. Great. So the first thing we're going to do is generate this command line. I've already generated a client library for it. And if y'all have never seen the proto-C, the proto-compiler before, this is what it looks like. The generator is actually a plugin for the proto-compiler. So while you're compiling your protocol buffers to get the type representations, you can also be generating a bunch of code. This is how gRPC works. This is how our GAPIX work. And this is how our CLI generator works. So as we see up here, I'm including the protos I want to generate for. I'm providing an output directory. I'm providing a couple options. One is the root command I want, so I'm going to call it lang, just for short. Call it lang, cuddle, L, whatever you want to call it. And also the import path of the GAPIC that I created for it, so that I can import that. And then finally, the service proto that I want to generate. Okay.
No command.
The split on 2 lines.
Uh-oh.
Proto-C.
The dollar sign,
Oh, where am I?
Proto.
Missing the common photo.
Oh, also missing that part. Thanks. My own copy paste didn't work.
No, you have to
Okay. There we go. It worked. Didn't say anything, therefore it worked. No complaining. Okay, so now we'll go over here, and if I ls the lang directory, here we go. So we have a bunch of different command file, Go files here. The first one being we've got a completion file, which will generate the auto-completion, the root command that we've named it lang, the service level command, and then all the methods on that service. And I'm just going to go into lang real quick. Install that bad boy. And we'll go over to this other one here, where I've got a token, and we'll see this. So lang, and boom. So this is the command line. This is what Cobra gives us, right? I just put in the commands, and it gives us everything else, which is really awesome. There's some global variables here, verbose output, JSON output, and so if you want to do some more parsing and whatnot with JQ. And as you can see, there is the completion command to generate auto-completion, as well as the service level command to start learning about the service, start calling the service. So I'm lazy, and I don't want to do any more. Oh, shit. Oh, shoot. I already have completion set up. But if I want to learn how to do completion, okay, so I need to install a Mac. You can install this bash auto-completion thing from Homebrew. And then if I want to set up the completion, boom, there you go. I already had it set up, so sorry, I'm a liar. But trust me, it works. And from there, you can start doing stuff like lang, tab, okay, I've got completion and language. This would be, if you had multiple services, you had a ton of different APIs. If I had a single one for a single CLI for all of Google Cloud, I could have language, vision, speech, all that stuff there if I wanted. If I want to do the language one, now what methods do we have? These are all of our methods. Okay, let's analyze. I want to analyze what? Something. Okay. More stuff. Okay, I'm going to pick that. And then what flags do I have? Okay, these are all the flags that this can provide. Some of these are global flags passed down from the parent, stuff like API key, server address if you want to target like a local server or something like that. Insecure if you're not using, if it's like a local host. And yeah, also from file if you want to supply your payload from the file rather than specifying everything on the command line. But I've got a command. I'm going to cheat once again. Hopefully it works, unlike last time. I've got a command here for you. OK, so great, it worked. What I'm doing is I set JSON output. I also set up I chose the one of, which was content. I wanted to use the content rather than a file URL or a GCS URL. The type of it is plain text, and I gave it some content. I just gave it the first line of the talk I gave, the talk description I gave tonight. And then the output from the natural language API was there. You'll notice that I also set up earlier, just so it wasn't in the way, a token that was used to make this call. And let me just do this. Well, just trust me on it. But Really? Do this. Lazy, just doing tabs the whole time. Oh. So yeah, so the generate command line will also, using Viper, which is awesome. Thank you, RT, for working on Viper. Well, you can also configure things from the environment, so what we're used to doing with command line interfaces, right? You can either provide it on the as a command line flag, but passwords, stuff like that, you don't want to put there. So environment variables might be a little bit easier to swallow. The structure of that is, the root command name, the service name, and then the corresponding configuration value. Because if you have multiple services, you might have multiple addresses, you might have multiple tokens or authorization things for those APIs. So each one has their own little configuration space. And yeah, so that's about it. If you want to look at the code, we can also do that. But that is all I've got. And if the only thing you take from this, if I will, boom, is CLI for everything. And instead of having generic tools that sacrifice the command line experience for API consumers, let's make better ones, and we can generate those for gRPC APIs, even for HTTP REST APIs. But I like gRPC, so we're going with that first. And yeah, thank you. That's all I've got. Nody on Twitter. Do we still have time for questions or no?
Yeah, would you be able to take some questions?
Totally, yeah.
So actually, I had a question.
All right, sweet.
So I worked extensively with the HashiCorp API, and they seem to have it's similar to, I always wondered why they had a CLI that was so well structured.
Mm-hmm.
And so are you aware of the tools that they're using to generate their CLIs? Are they using tools? I'm just curious if anybody's.
To generate their actual CLIs,
yeah,
or if they were handwritten?
HashiCorp has beautiful CLI, and they maps directly with their APIs.
This started they started in Ruby with Vagrant. Vagrant already had that style of sentence.
Okay.
And I think
was generating the CLIs from.
no, I think
API?
the CLI themselves, this kind of making a sentence.
The style of it.
Yeah,
Okay.
the style that was their trademark.
Right.
So I don't know about HashiCorp and how they actually generate or how they end up creating those tools, but maybe they have some developers that are just really, really good about making sure everything maps perfectly so that the experience is fluid from all parts. But it'd be worth looking into. Do they know if what types of APIs they have, if they're gRPCs or HTTP?
So
JSON?
I've used their HTTP APIs mostly for Vault and other things, and
Cool.
it seems like it's like their API is the core, and then they have a front end which could be a CLI,
Mm-hmm.
or it could be a UI, right? So it's like CLI is like a front end for your APIs.
Mm-hmm. Yeah, and I find that it's I'm there on the command line a lot, and I prefer honestly to use command lines over web interfaces, but maybe because I'm assimilating into a Borg, and that's what I like. But
It's just another. What I meant was it's another just a front end.
yeah, definitely.
Yeah, cool.
Other questions? In the back, you were first.
Myself. Right?
Yes, yeah.
Yeah. So actually, in the beginning, you gave a service.proto argument. Is that local to your machine, the service.proto file, to generate a CLI?
Oh, to generate it.
Yeah.
Oh, yeah. So
is that local to your machine or?
yes, that is local on that is on my machine. Yes. It's also on GitHub if you're interested in looking at it. Google APIs is the organization, and Google APIs is the repo, and it has a lot of Google Cloud's protocol buffer descriptions. So all the service descriptions are there.
Also, you mentioned something about OpenAPI. Where does that fit in your talk?
Oh yeah, so I was focused on gRPC, but when I mentioned OpenAPI is because Kubernetes, the kubectl, the CLI for that, they describe their APIs with OpenAPI, and Tim actually did some really cool work with them about So they download, at first they were downloading their OpenAPI specification on every command. It was like a 1.3 megabyte file, which is just absurd to be downloading every command. You can imagine you're literally watching it load on your command line. And they wanted to make it better and faster, but they still wanted to use their API scheme, the API definition, right? So Tim built a tool that takes that description and compiles it into the kind of like a protocol buffer binary representation. Is that right, Tim? Am I fair? Okay. Yeah, protocol buffer binary representation of the description, and then that's much easier for machines to parse. It's a lot quicker to download, and they started caching it as well. So, but they use that to then generate command structure, payload validation. Yeah, it's all based off the schema, which I think is a cool idea. I like schemas. Yes.
When you ran your proto-C command and then it generated a bunch of Go files, what are those? Are they like per method? Like what's the?
Yeah, the structure of that.
You have one proto file with the service and RPCs. Are these files the?
Yeah, this is what you're talking about?
Yeah, right.
Yeah.
Those are the method, the RPC themselves, or what?
So these are actually, this is actually just the command line code. So there's another library I generated for the client library, and there's also another library I generated for gRPC. So gRPC is the foundation, and you generate some stubs with some basic stubs with gRPC, right? Those can totally be used to develop an application. The more complicated behaviors that we have in our APIs, like long-running operations and pagination and whatnot, that we want to make it easier for developers to use, that's where our generated API clients, the next level, really help make the developer experience better. And then from there, I'm using the GAPX to generate a command line interface. So the command line interface uses the GAPX under the hood, like in the code, to actually invoke the API. So this is just the code for the command line interface. The other two things are separate packages, Go packages elsewhere on my machine.
And you can create a single binary out of these guys when you do the install.
Exactly. That's another reason why it's like perfect for Go to build command line interfaces. Is there's an awesome framework for it, Cobra, and cross-platform compilation. You can ship a binary. It's super easy, rather than having npm install -g or something like that.
And then do you split those, like, let's say you have like a full-blown application, and then you create a CLI for it. You don't put them in the same repo, I imagine.
Totally up to you. We do that with Kiosk, right? We have our command line interface. We actually have two command line interfaces, the handwritten one and the generated one, in the same repo. And yeah, we just put them both there. But totally up to you. I mean, if you want to put it on your dev portal as a binary, just a download button, that's cool. If you want to separate it and put it on GitHub and do releases from there, also fine.
You don't put it in your CI, right? You don't generate the at build time, you commit your generated, just like where you commit your proto, your Go generated code, you're committing the generated
command line interface, yeah. Yep.
Okay.
And as part of CI, though, we do also generate things to test them. Actually, one of our applications, it's like a testing API that all of our generated APIs test against, is it generates a command line using this, and you can then use that to test things, like automate that. So you could even do it all in one shot, generate it, install it, run it right there. Someone was a question behind them. Yes.
Sorry. How do you connect to a gRPC server?
How do you connect to it?
gRPC server.
Yeah. So we have these client libraries that they abstract away the transport stuff. So under the hood, it takes a host and it's dialing that host and gives you a connection, and then the clients maintain that connection, and then you're just invoking from the code. It looks like you're just saying new client dot analyze entities, and then it does all the connection under the hood. Because that's part of improving the developer experience for us, is abstracting away all the networking stuff, so you don't have to worry about it. With Google APIs, we have a default host that is in production. So like it's language.googleapis.com. So we always know that that host, we can generate a default client for that. Oh, I went to sleep, sorry. And abstract away all that, all the networking part of it. There's automatic authentication because our APIs all follow the same practices there. You're really just new client, invoke a method. So.
Okay, thank you.
Yeah, definitely. Yep.
Can you do bidirectional streaming with this CLI also?
Yes, you can. Yeah. So the approach there was I played around with the idea of like, okay, maybe I can start up like reading from the server stream, the server-side stream over here, and I'll print it to like this file, and then I'll like read some standard in here, and it was like super wonky. I think the best way to, with the CLIs at least, is the best way to do it is you provide a file with all your payloads in it. There's like a bunch of like JSON. It's JSON proto, so it's a JSON representation of the proto payload. Provide all those messages, send them all off, and then you get it all sent back. But yeah, so it does do bidirectional. It does client side, does server side individually, depending on what you want. And with like client side streaming, you send a bunch of messages until you send the termination sequence, stops, and you're good to go. Same thing with server side. It'll just keep reading until you're done. But yeah.
And sorry, one more question.
Mm-hmm.
Does it enable like debugging capabilities? Like in verbose mode, I can see some like logging printout from the command line.
Yeah, so there is verbose. It's not as verbose as I'd like it to be. That was lower on the list of priorities, but would like to have more verbose printing around like what's more of the networking stuff in case you want to get into it and start debugging that. But right now it pretty much just prints everything that you're sending it and everything it's receiving, unfiltered and unformatted. Yeah. They're not super useful if you're trying to debug a connection, but hey, we're accepting pull requests. So. Like every other open source project. Yeah.
Do you have any implementations on other languages like Node or something else?
So not with, actually there is one. It's not gRPC related. It's, so Google has this other specification format called discovery. And that's what a lot of our HTTP APIs are documented in. And there is this one cool generator that someone wrote, and we discovered it kind of randomly in our research for this project, that he's generating Rust CLIs for all of the HTTP APIs that Google publishes. So there's that. I did look at that, compared some of what the CLIs looked like, and weighed how they were formatting inputs, flags, things like that with how we were doing it. There's also the intricacies of gRPC with streaming and whatnot. Those are different from, obviously, Discovery HTTP APIs. So there were some differences, but definitely looked at that. As far as gRPC, I couldn't find a CLI generator. There's a ton of reflection-based CLI tools. Some that take a different approach, like gRPC curl looks a lot like curl. You should invoke it. Some that do that are written in Node, but do like a REPL, the read, evaluate, I forgot what the P is for, loop. And so you're kind of like an interactive session while you're sending requests and whatnot to this API. Also uses server reflection though. Yeah. As far as say generators, I couldn't quite find them. If you have any ideas of other ones, let me know. I'd love to see them.
Anything that just uses like Swagger for the?
No, I don't know of a CLI generator for OpenAPI specifications. OpenAPI, formerly known as Swagger. Yeah. Do not. That'd be cool though.
Opportunity.
Opportunity. There's a project. Okay, great. If you have any more questions, feel free to find me or tweet at me. No_d_here. Just one more plug, if I don't mind. Yeah, there we go. Cool. Thank you. Maybe next. All right. Now we've got Tim. Oh, I don't need this.
How'd you get your theme all black?
Latest OS X has it as an option. Dark theme, they actually listen to developer response. But I didn't have my mic on for that one, that was good. Let me just make sure my windows are all set up here. All right. Works good. So I'm actually here to talk to you today about a project we're working on in the community called the Gophers. And it's supporting the ecosystem and those who've helped build it. So just a quick update on who I am. My name's Tim Heckman. I'm a site reliability engineer here at Netflix. I work on the team that's responsible for global streaming and signups. So no pressure on that on-call shift. And I'm on Slack, I'm on GitHub, I'm on Twitter. So I'll put those there. If you've been on Slack at all, you've probably seen my picture and seen me talking a lot in the general channel. And so before I get started on the Gopher stuff, I just want to provide an update on the Slack workspace. I did a small bit on this at the GopherCon last year, lightning talk. And so I just want to give some stats on what the workspace looks like today. And so we have over 36,000 registered members on Slack. Managing that is fun. And over 4,000 active each week. As people work on projects and do different things, they come and go. And so it's actually changing a lot. Between 7,000 to 9,000 messages per day, over 975 channels. Most of those conversations are in public channels. In the last month, the most 15 active users sent over 42,000 messages. 15 people. And that means there's nearly 5 million searchable messages because we have a Slack workspace that retains all history. So every conversation that's happened in a public channel is there. If you have a bug or some issue, you can go there and search for it, which is awesome. And not enough people use that because you can go there and just type that thing in and hope you got some search results. And so I think the community we have today is arguably one of the most open and welcoming I've ever been involved with, and even just kind of been a member of. You know, I've been there for a few years, and I've heard a lot of positive feedback from new people and old people about the experiences just there. People help out. People really care. And it's important because community building is challenging, right? It takes a lot of work to build a group of people to come together and to make it work out. And especially hard when you're using a product like Slack, which is built for companies with HR departments and not people on the internet being people on the internet. But we're lucky that the people in the community care enough to kind of police this themselves and to correct, you know, those misalignments on behaviors without involving the moderators. And so we're very lucky that in terms of admin interaction, there's none, because everyone else kind of self-corrects and kind of shuns those that aren't being welcoming and polite. But the pains of still working in Slack exist. And also, you know, especially new community building is hard. Not just, you know, building once you've created it, but Go is still pretty new in terms of the languages that exist today. And you run into a lot of scenarios where you start fielding the same questions. The same things come up again and again when, you know, good patterns and good answers haven't existed just yet. And some of that is, you know, you kind of experience it working like an open source library. You have to work through problems and iterate on them and find fixes and roll them out and see how it works. And I'll just save the talking about Slack challenges for another talk. That's a whole long one on its own. I've thought about it for a while. But the challenges that we face in the community aren't really focused on the community themselves. It's not the community that's having a problem. It's just growing pains. And so that's really where the Gopher started. And so when you think about the last few years, we're really in the age of the Gopher, for lack of a better term. Don't coin this. It's pretty terrible. But when you think about that number in the Slack workspace, the number of registered users, you know that's just a drop in the bucket. That doesn't really reflect the whole ecosystem, the whole community. It is one small piece of everyone who's there. And it's even more impressive when you consider the age of other languages that most of us are familiar with. Yes, there's a Cold Fusion reference on there if anybody used Cold Fusion. I did decide to throw that on there as a joke. But Perl 5 came out 3 years ago. Perl 5 is probably most of experience writing. That's still 23 years old. Go 1.0 is 6 years, 10 months. Now I know Go was officially announced in 2009, so I'm kind of cheating. But I figure the 1.0 release is probably a good stepping off point to kind of compare. And so it escalated pretty quickly. We have so many tools relying today. Docker is written in Go. All these things we now take for granted that 6 years ago couldn't have existed. The maturity wasn't there yet. But because we're so young, we have this problem with ecosystem volatility, right? You don't really know what packages to use to solve problems. It's hard to know what the quality is, whether the maintainer is going to be there tomorrow. And so it becomes a lot of this weird, deciding which one to choose and which way to go, which reminds me of this pretty famous XKCD comic. I'm going to read it out loud just in case anybody has trouble seeing it, but it's XKCD 927 standards. How standards proliferate. C, AC chargers, character encodings, instant messaging, etc. The narrator says, situation, there are 14 competing standards. So Bob says, 14, ridiculous. We need to develop one universal standard that covers everyone's use cases. And Alice says, yeah. So in the future, the narrator says, situation, there are 15 competing standards. And so we're in this position where the environment, the environment and the ecosystem are still in flux. We're still figuring out what packages to rally behind and which ones solve our problems best. And so really, the way the Go first started was to try to help solve some of the problems with the Go ecosystem and the users that are facing those problems, and not really the tools we use in the community. We're kind of figuring those out. There may be some overlap, but Slack and those sort of things, the mailing list, they work well. And so as the ecosystem has matured, some packages have started to emerge as kind of the way to go forth. Cobra is a good example. I'm glad that kind of got brought up. But there's a lot of projects that compete with each other, and they do a lot of the same things. And now you kind of have this weird problem where there's no community rallying behind that package, right? And it makes it really hard then to know which package to use, and it really increases the likelihood the maintainer is going to go away. And I said community solutions lack the common solutions lack the community. Now the latter point about these solutions losing maintainers is kind of contentious because it depends on what goes on and what happens. But if a package loses a maintainer, the only time you're going to know it is when you run into a problem. And you go to that package repository, look for an update, look for an issue, and it's not there, right? There's no updates. There's 38 open PRs, and they've been sitting there for 3 years. But of course, that could be the natural order of things, right? The package lost, right? Others were better. It should be deprecated. It should go away. But we're not in that state yet where those packages have reached that point. They're still there. They still look active. We still need to decide whether they're valuable. And part of the challenge is that maintainer might have had a family emergency. They might have had a baby, and they've had to step away. And they aren't abandoning it, but they're just not available. And so really, in the ecosystem, we're standing on the shoulders of giants a lot of the time, right? A lot of these packages were built by one person. They're maintained by that single person. We rely on them for the security updates, the code reviews, the triaging of issues. And we import those packages and use them every day. But it's hard for us to really know what that tax is on them. And sometimes their legs get tired. You're standing there, you're doing a lot of work. After a while, you need a break on that. And so burnout is what we need to help prevent as part of keeping the ecosystem strong, to make sure those giants that are there can still be part of the ecosystem, not to be relics of the past, but someone or something that is actively contributing to what we're working on. And so what kind of leads to this event where there's single individuals maintaining these packages themselves and kind of carrying this burden? I think there's really two problems or two focus areas in that. There's the non-technical and the technical problems. I think the first one is just trust, right? It takes time to find someone who wants to help maintain that package for you and really cares about that. And then you have to build the trust on top of that. And collaboration is more effort, right? If you're trying to envision your idea and bring it to fruition and see whether the idea even works, having to then collaborate closely with someone is a tax. It's a great thing to do, but it's still a tax you have to pay to make sure you're in line with what they're doing and you're kind of moving the thing forward. And some just might not want to give that ownership away. They might want to really, carry the torch there. And there are some tooling limitations, right? GitHub in some ways isn't the friendliest with doing collaborations. If you have a repo on your own user account, you can't grant anybody admin access to that repo. only you can administer it. So even if people are taking it over with write access, if they need anyone added or removed, you're still on the hook for that. And so the way to get around that is create an organization, put your repo there. You can kind of solve it. But I feel like we can do more collectively. I feel like, because we have these packages that exist, it's a hard time choosing what to go after. We really think there's more that we could do. And that was kind of what incepted the idea for the Gophers, is that there was a few of us that felt like there could be value here. And so, I use this quote, my original talk that I gave, the lightning talk, but I think it still holds true. The whole is greater than the sum of its parts. The ecosystem, the community, I said, is very powerful. And I think we need not forget that. But returning back to the problems that we have, there's some emerging patterns we noticed in what was being asked and what was confusing people. And you had things like, hey, I have problem X. Which of these 4 packages should I be using, right? What should I choose here? I'm using package X, and I've noticed it has 150 outstanding issues. Is that the right one to go after? Kubernetes has hundreds. But there's harder questions and worse ones to get asked. Like, so there's this UID package that's not generating unique UIDs. Should I use another one? Yes, but the hard answer there is, well, then what do I use? Which package should I trust if the one that has the most imports can't be relied on? Where do I go? And that was what really, I think, was the inception there. Is there's a need to identify trusted packages for solving problems. You have to know where to go, what to look at, who you can rely on. That's hard in our ecosystem today. We have some good repos, some good people like SPF13 and others who have come in and kind of built packages that we can rely on and trust today. But there's also a need for trusted package maintenance resources. People you can rely on, kind of pull in as a tiger team to help out, maybe take over the project if you're really, you're going on paternity leave or something. Something is happening where you're going to be away. And really, we want to help out and lift the burden off the shoulders of those maintainers, right? Make them feel like they can go out and work on other projects, spend more time doing things, but leave the triaging to someone else who they trust. And that, that UID package was really the inception for our effort. And it involved a fork of the package. The goal was really to bring together a group of people that are diverse backgrounds, diverse companies, diverse experiences. Maybe some are very senior, some are more junior. Because we feel that there's not value in homogeneous experiences and backgrounds, deciding what's good for a package or the ecosystem. Burdens of package maintainership should be shared, almost like a communal effort. We should pick up things. Someone's got to take the trash out. Someone's got to, you got to line those things up and build people that are willing to kind of do those dirty jobs, like Ro used to. And there's a bet that there's an opportunity to pool resources to solve larger problems. If we have those diverse experiences and people, we might be able to find common problems or issues that we're having across companies, across technologies, and even if we're not solving for it, at least document it down, write an experience report, and have something we can share from those different viewpoints. So the execution, so kind of explaining how we want to do this. I talked about it a little bit, but contributions open to everyone and anyone. The gatekeepers are going to be some informed captains, for lack of a better term, on those repositories. But really, anyone and everyone should be able to contribute and have a voice and have a say. And we hope that people get to work on things that are important to them. But ultimately, there are shared responsibilities that, things we have to do, things that might not be as interesting, but we all have to figure out a way to make them work. And part of that is building that responsibility and that shared mutual respect inside the group, so everyone kind of feels ownership and care for the work that comes out of it. And feedback should be collected from multiple people before making a decision. We shouldn't be deciding something based on one person's opinion, who's the loudest speaker or the strongest voice in the room. And we want context, not control, with consensus building, right? You want to provide the information to give people the details they need and then decide kind of what's best. Of course, at some point, you're going to need some escalation process where you decide. But the idea is that ideally, if the right idea is that obvious and we can debate it in a public forum, we should come to the right solution, or at least the 80% solution. So far, we've only considered packages that are in need of a maintainer. We don't want to get into sort of political disputes in the middle of a fork or anything like that. We are kind of trying to keep it amenable, and so that we can take over things that are easy to move to, and that it's out of respect for the original maintainer. And we try to limit it to packages that have a certain level of maturity and adoption. We're not really feeling like we want to do initial development or R&D on that package. We want to kind of get something that has somewhat of a mature API and then continue it on from there versus doing all the experimentation, because it seems like it's probably not a good use of our time. Right? When you're doing that sort of thing, it's a very big time effort, a lot of customer feedback. we want to focus something more. And so right now we have 2 active projects. And we kind of limited taking them on just to see how modules would change, how packages are adopted or imported. When you rename a repository on GitHub, they set up redirects for you and do all those sorts of things. So we wanted to see how those workflows would work and make sure that got hammered out okay. The 2 packages we have right now are UID, we talked about already, and a flock package that I had built a few years ago that has some adoption in the community, but the API is very mature, hasn't changed in years, but just a place it could go so others could watch over it too. But we're still working on things this year, right? Like we want to ramp up and take on more things now that modules are starting to get leveled out. We're starting to get stabilization on how they work. So we're getting more confidence in knowing that we can adopt these packages in a way that'll be good for the community and not cause disruption. And so the things we're looking at, Logris, you've heard of Logris. We are pretty close to finalizing the migration towards that. This was the one we were worried about most with the module stuff and how it would change and making sure we did not break current importers of Logris, because there's thousands of gists out there where Logris is the logger they use. So that keeping this working is very important. So we've actually got some requests to maybe talk to the Viper group and see whether there's something we can do there to help. Not necessarily adopt it and bring it in our organization, but provide resources there, as they need it. And there's also Gorilla WebSocket, where we're starting to get into the process of building trust with that team, working on triaging issues, doing those sorts of things, so they feel good about us getting involved more with that project. Trust is the very common theme here. We want to make sure people trust us taking over these packages. We're doing it right. We don't want to mess things up while we're doing that. And one of our longer-term things, I said I wouldn't talk about Slack, but how can we improve open Slack community workspaces? And really, there's no moderation for users. It's very hard to control things. And so there are common problems that we've heard about now talking to others who administer Slack workspaces that sound like we could all group together and find a solution that works out for us and everyone else. Whether it's Go or not, I want it to be Go. But we want to start thinking about this after we get these packages adopted and ramp up, because we think there's an opportunity here. So now we're going to be ramping up. We could use more resources. How can somebody contribute? One is just helping review requests for adoption, right? People are going to file issues saying, hey, I have this package. I need help. Or, hey, there's a package that exists. They said they need help. And so help triaging those. Definitely triaging and managing issues on the packages we've adopted, doing reviews, and providing any feedback in an area we can improve, right? You may not be working on the projects, but maybe we commuted something in a poor way, right? Maybe we used something we could have said better, and we could take that feedback. The other is, if anybody is good with designing static websites, I can tell you what I'm not good at, designing static websites. And so if somebody willing to help out designing a Hugo website, if someone who can cut a deal with an open source group, happy to talk about that and see that we can throw some change their way to get something built up. We have a static site now, but it just feels kind of cookie cutter. So hoping something a little more personal would kind of be the idea there. So if you know anybody, let me know. And so how to get involved. This is a QR code for the Slack workspace. If you are not on the Slack workspace, snap a picture and it takes you to the invite page. You'll probably see me chatting in there in an hour or so if you join in. But we have a channel in there, hashtag Gophers, GOFRS. We also have the GitHub org and the current static site, which also explains how to get involved, how to join our organization on GitHub and start that process. And so that's actually it. That's the end of the talk there. Happy to answer any questions if anybody has, but it's definitely not as interesting as the talk I followed, so I'm not expecting too many. Make it too easy for me.
Tim, I have.
Yeah. Oh, sorry. Go for it.
Yeah, no problem. So, Gorilla is like this huge Go project, right? Tons of packages.
Yep.
Obviously, like a sort of overwhelming amount of attention kind of focused on the people who work on it. Why WebSockets as opposed to other packages there? And how, can you maybe talk a little bit about how you approach big projects like that?
Yeah, definitely. So the WebSockets one is very interesting in that, so there is a WebSockets package under the X repos. And the first paragraph says, don't use this, use Gorilla WebSocket. And so those extended repos that we have, it recommends not using their API and going elsewhere for it. And there was also an issue on the WebSocket repo asking for maintainers, that there was a need for this. And so when we started this conversation, we were like, what packages or which repos or which projects could really use help? And someone was like, hey, I remember seeing this issue on the WebSocket repo. And that was kind of where it started there, is we saw a need there. We know that, if someone searches for WebSocket, it's going to be the first thing they hit. If they hit that X package, they're going to go back to that first hit anyway. And so I think that was the big driver there, is they needed help. It's a well-known project. Thankfully, it's already in an organization, so that makes the team management and stuff much easier compared to it being on an individual's account. And so there are things that make it a much easier, for lack of a term, sell on saying, hey, there's value in doing this. And it's a very active project, lots of issues on it. It's definitely an overwhelming thing. And I think, not overwhelming, but it's a little daunting, I think, when you look at it. And I think the maintainers really want to make sure that if we're going to help out, that we do build trust incrementally to get to the point where they feel comfortable handing it over. And so that's, starting to triage issues, recommending ones be closed, going through that initial, hey, I'm a new person here kind of thing. I'm hoping with a few months of that, we'll have a trust at least enough that we have the right access, just so we can start to close those things, merge things that need merging, do releases. But a lot of it is going to be just spending time building that trust and making sure what we do is in the best interest of those in the ecosystem. And we're not changing things in a way that's going to break stuff. We're not adopting something that's going to be too contentious or cause problems for others. And so it's where we hope that diverse background of people will come into play, is that we can kind of pull them for input and get their feedback and then make that final decision on things to do or things not to do.
Have you modeled this after any other, like this is specific to Go, but there's lots of other open source projects, right? Has any other open source project had kind of this triage team that has worked successfully that you could kind of model this after?
I mean, I think you actually see some of it in the Go language itself, right? There's a lot of tickets that are replied on and triaged by non-language team people initially. And so I think some of the inspiration was taken from just how people are active on commenting and trying to help triage those issues directly. I think looking at it, you do have projects out there which kind of, I mean, it's the Apache project, right? It's kind of similar. It's a much larger project. We're kind of not looking to become a nonprofit yet. I mean, there's a lot of challenges there. I think it's worth looking back at the scaling problems they had and the challenges they ran into and see how we can learn from them and scale it up kind of slowly and see how things go. I think it is, I mean, really, I think the core concept from it came from the idea of, like, if I get hit by a bus tomorrow, who else is going to maintain this package, and who's going to help out with that? And that just having me as one person feel like I can raise my hand and spend all my time helping out really isn't going to make the ecosystem better. I'm just going to push that single point of failure onto another person effectively, and we're still back where we are. And so it's how can we bring people together without it being a full-on organization where you work there or people are employed by it, and just kind of make it a volunteer effort where we're trying to do things in our spare time. Some of it is taking those learnings, iterating on it, finding more people to do different tasks, kind of handing them away, giving people the power and giving them the responsibility to make changes and feel like they have the say. They can, if they want to merge the pull requests, they don't have to wait for someone to do it. If enough thumbs up are there, go forth. You have the power. And so I think it's just trying to model it after open source projects that have succeeded where they have multiple contributors, multiple people working on it. And they have the community backing that project where even those who can't write are commenting on tickets, asking tickets to be closed, doing those sorts of things. I think there was someone in the back first. Yep, go ahead.
I was just curious, what points do you have of rejecting an open source project?
Yeah, I should have put that in a slide. So I think one of them obvious is, like, this thing's experimental, right? It's not something that is even near a 1.0 in any near future. And so I think that's an immediate one. There's some where they rely on a deprecated API, something that is going away or has been deprecated by something else. Then you should probably move to the new thing. We probably shouldn't be supporting something that has a paved path forward. And so the better option there is to make sure to fix any critical bugs to help it so people who are still using it, right, get it to a state where maybe we open PRs and got people to merge them. That way the current users are okay, but with the big warning saying, hey, you should actually go over here when you have a second, I think the other is, looking at packages that are like, left patty, right? It's a very small package where you could just copy the code very easily into your repo and be done with it versus maintaining a whole dependency there. I think some of those are things where, like, well, if there's been no commits in 2 years and it's 300 lines, it's probably done. It probably doesn't really need any further commits. And so I think that's another case too, is if it seems like a small package where you could just duplicate the code without much effort because it's not going to change, probably not a good use of our time. You could argue that it wouldn't be any time sink because nobody's opening issues on it, but it's just trying to make sure we keep the radar focused where the most value can definitely be. And I think you were next. Yeah. Yep.
I'm just curious about, like, your plan, if you have any, for like scaling this. Like, let's say you have 200 repos or 200 packages, and I don't know, 15 or 20 or 30 guys in the organization? Like how do you this?
Well, I think some of it is making sure that we self-check ourselves, right? We're not going to just willy-nilly accept everything with the worry of that, right? We don't want to stretch ourselves so thin we end up in a very similar spot where it's one person per repo or something like that. And so part of it is going to be getting those people that are kind of the stewards for certain packages, right? They're kind of the administrators for those things. They have the extra access when the others who are interested in working on it have the right access. So there's kind of the normal bucket of people who can contribute to multiple projects, if they're on there. Making sure we do code reviews and requiring sign-off from like 2 people or something like that. So that way, things can go through, people can confirm it looks good. And also just then trying to avoid someone going on too many things, right? So keep them focused on a certain number of projects, provide a pool of other resources there, limit the total number of repositories we're actually maintaining. As we get more people and get more help, or somebody's like, hey, I have this package I'd love to maintain, I'm happy to help do it. If you guys want to contribute to it, we can see whether that additional resource plus ourselves can pick it up as well. And so it is really like a gut feeling, and then asking everyone, hey, this is my gut feeling. Can everyone else kind of say what yours are? Are you in favor of it? Are you against it? If you're in favor, why? If you're against it, why? Trying to explain what the pros and cons are, and then just weighing that as a group. The consensus or the weight seems to be no. Then it seems like it's good to say no. And just with a caveat, if it seems like it's a good thing in the future, reopen the ticket, right? Open a new issue. We're happy to revisit and have the conversation again. But right now, we don't feel it's a good choice for these reasons. And that's part of it too, is we want to make sure if we say no, there's a reason behind it. We can say, hey, we talked about it. We had these concerns. For these reasons, we decided not to go with it. At least that way, if it needs to be revisited in the future, we kind of know what data existed back then, and then know what to consider in the future, and then compare the two.
So I'm, I've long history of writing Java, and so I'm thinking from the Java world, things are very mature. So like there's tools, right? That'll do like scanning across all of this and tell you like, these dependencies are deprecated, and this is what you should use, and you can use a tool to do the conversion from what. So does the community have? So I guess it's bouncing off the same question he had, like what if you had 200, and like how would you, like how about the tooling around, building something like this? Could something be done to automate? It's like scan all GitHub and see, who's using loggers, for example, and like what's, I know I also use loggers, so I know that that's a pain point for right now.
I think that's one of the things that I think I forgot to mention it in kind of our plans for this year is trying to do more targeted engagement with the projects that use these things. So going out and looking at everyone who uses Satori Go UID, and at a minimum open an issue, right? And say, hey, we discovered that you're using this. We recommend it gets moved over for this reason. We could then look at those projects and decide how we can spend resources to open PRs to do the migration form. At least the UID one is very easy. It's not too much of an API change between ours and the previous one. But I think that's what we're looking to do for those, is to just go through, use any of the public GitHub data available to do so. Longer term, as the module stuff extends out and there's different metadata proxies for the package data, that might help out with some of that sort of digging. I'm not sure what dimensionality we're going to have at the end of the day with that metadata, and I'm sure we can iterate as more needs come up. But I know there are tentative plans about having deprecation notices and security warnings and those class of things tracked in that sort of repository. So the deprecation stuff's harder because we don't have a good metadata store for that today. We could use archived repositories as a signal, but not everyone is archiving. It's fairly new. And so there's lots of now unmaintained packages that aren't archived, and if the person's busy or gone, they probably won't be archived. And so without that central store that we even do some curation on, I feel like it's going to be hard to do that in a tooling way. I think the best we can do, and we've ran a script for it once, is to look at projects that have lots of stars that haven't had commits in a while. Stars are a terrible metric for the actual popularity of a project. So using the number of imports is probably a better metric. And the idea is to maybe look at that too, number of imports, last commit date, get an idea of whether that project could use some help, we should engage, or maybe it's done, right? The project is finished, there is no issues, there's no PRs, we're done with that thing. So definitely some sort of engagement to try to get people to convert to the new packages, so they're not accidentally pulling in a UID version that's rendering half zeros instead of a UID string or UID byte slice.
So I have a second question. So I spent some time with like bindings, like Seago bindings, and they're also like scattered all over, the hemisphere. So I don't know if there's any plans to pick those up because those tend to be hairier, sort of a.
Yeah, I think that's part of the challenge too, is making sure we have the right resources to do those things. We don't have the people with, the comfort or really the urge to support those projects. It's a dangerous thing to pick up. And so I think we're also, I guess to answer that other question earlier again, is that's one of the considerations too, is do we have resources that have enough expertise in this area to be mindful and thoughtful of changes we make and to understand the ramifications of that? So depending on what the C library is and how hairy that integration is, it could be a yes. If we have somebody who's worked in that space and is familiar with the code it's interfacing with, the libraries at least, that could be an easy sell. But if it's like some esoteric library or some machine learning thing that is interfacing with a C++ library, that might be a little less fruitful in terms of taking it over and getting value to the rest of the ecosystem. I'd say it really depends on what the project is, how widely it's used, and how hairy those interface points are. One in the back, and then over there then.
Speaking of the resources, as an open source maintainer, do you have to maintain balance between paid work and open source? And if you do, how do you do that?
Yeah, I mean, for me, I try to set time blocks during the week, kind of like on my calendar, my personal calendar. This evening time, I tell my wife, hey, my calendar's blocked off. Sorry, you have to submit it. Give me a request for a meeting, and then we'll talk about that. I have not done that yet, and I'll probably regret it if I do. But no, the idea is I try to dedicate time and just say, hey, I'm going to work on these things during this window, these types of things, right? I try to split that up. Try to use some weekend time to do that. Try to use some evening time. I'm very lucky that working at Netflix, where I am, work-life balance is very important to the company. And so having done startups for many years before, I actually now have time to work on those projects and actually have blocks of time where I'm not coding at home in the evening, which is very nice. And so I've tried to use the structure I'm able to get working at a place like Netflix and then build my own schedule at home so I can dedicate that time and spend time with my wife, do my own personal things that don't have me focused on the open source stuff or, my own kind of refresher. That's what's worked for me so far. We've only been doing it for like 3 or 4 months. So jury's out a little bit on that one, but so far it's allowed me to just say, hey, all right, I need to focus on this. We can talk about this in 2 hours. It's on my plate, and then 2 hours later, have that conversation, or go take the trash out, or do whatever I need to do.
Have you ever looked into the Debian ecosystem?
I mean, I've been a Debian user in the past. I've kind of looked at how they, bring maintainers in a little bit, but I've not done a full deep dive on it. It seems fairly open in people starting conversations and getting kind of the trust building done to get to the point where they can be then relied on to have their keys set up and they can then push the packages. I think that's part of what we're trying to do is I mean, one, making sure we're doing code reviews using code signing and things that we can validate that those users who are validated to push can push and they push signed code, blocking anything that doesn't fall in that, because we're worried about credential compromise. We don't want someone's GitHub account being compromised in this organization impacting things. So making sure we block releases in our toolkits that won't let this happen. And even setting up alerts, right? Checking the commit history, and if you notice a rewrite, page someone, right? Wake them up, call them, because that's a problem. And so we haven't gotten that far yet, but it's kind of some things we've talked about in some of those areas, and that's a little different to the question you asked. But about the code signatures and trust that the code you're getting, the thing you're getting is built by a trusted person. That sort of concept we've gone forward on to the point that we internally won't accept commits if they're not signed with a PGP key. With PR, we were projected to sign the code. Now, external contributors not in the organization will accept their PR, but the merge PR has to have that PGP key, right? Like one of the maintainers has to commit that locally, sign it, and then we can say, all right, this was signed by a trusted party. The commit kind of gets in that way. And so
More generally, as resources and as history, right? Debian has a long history of doing these kinds of things, and they may have some people that are interested.
Yeah, definitely. I definitely am going to reach out. I should reach out to the mailing list, or at least somewhere there, and see who the best person to talk to be. I definitely want to do the same with other groups too. Different package maintainer groups. Talking to. There's other groups that have done similar things in smaller capacity in other languages, and kind of talking to them and see what their feelings are and the challenges they hit, even at the smaller scale. Definitely on the radar of things to start doing like in the first quarter of this year.
So there's a GopherCon talk from Michael Stapleberg on the Debian ecosystem and making packages for Go. So if you're interested, please also on Twitter.
Cool. Yeah. So there's a talk, GoProCon talk on Debian packaging and the ecosystem. So yeah,
Very cool talk. Yeah.
check that out. All right, cool. Any other questions? Perfect. Yeah, thank you so much, everyone. I appreciate it.
Hi, everybody. Am I? Yeah, I am. Kind of loud and echoey. Hi, folks. I want to say thanks first to Artie for organizing the event before we have kind of the last talk. These happen almost monthly, which is kind of an astonishing achievement, actually, if you think about it. So thank you again for organizing. So my name's Joe. I'm an engineering manager at this company in San Francisco called Lightstep. We make tools for understanding distributed systems. I'm going to talk a little bit about Go modules, a dependency management thing for Go. Why do I care about Go modules? Well, my team at Lightstep, we have about 30 programmers. We have about 15 Go services. We've been building Go services there since version 1.5. We deploy to multiple kube clusters in different environments. We deploy parts of our software on premises to customers. We build it all out of a mono repo. We have this like fairly complicated software environment, and managing the dependencies that we rely on is like a huge part of making the team productive, making things work well, avoiding breakages. A little personal trivia, my first Go app was for 1.0 back when I worked at Larry and Sergey's Protobuf factory. It's really a treat to get to talk to you as a community involved in the language. So what do I want to cover? I want to motivate what we're talking about a little bit with the general sort of dependency management problem that you see in software. And we'll talk a little bit about the history of Go before we had any official dependency management coming down the pike, and a little bit about how GoMod does some unique things in dependency management that I think are pretty interesting and are worth understanding if you're thinking about using the tool. Where we're at with the overall tool ecosystem for dependency management using mod, and kind of what's coming in the near future. So this is largely like an experience report from Lightstep and our sort of use of dependency management. So most of you are software engineers, you're pretty familiar with the general dependency management problem, but just to motivate it a little bit, imagine you're building some binary A, and you import libraries B and C, and they import libraries D and E, and somewhere down the line, they all rely on some strings package because your language doesn't provide good string utilities or whatever. So, you know, we need to find all that software. We need to fetch it. We need to have it available for the compile. If we're in an interpreted language, we need to have it available at runtime for class loading, all those sorts of things. It's relatively simple. It's essentially graph traversal. But every time something changes, you get to solve an interesting, complicated problem. Let's add versions to the mix there. As soon as you have C version 1, which relies on E version 1, which relies on F version 1, and you want to update to C2, well, it brings in a new package G. It relies on some updated version of E, which relies on an updated version of F. Depending on what your language ecosystem looks like, you may or may not be able to have F1 and F2 available at either build or runtime, right? This is like where everything used to fall apart for me when I programmed in Java. Something would change upstream from me. I would have 2 versions of an HTTP util library. I would need to like run some shadowing thing to make them have different names. This is where like you spend a day looking through, you know, config files. You spend a day looking through Maven logs or Go logs, trying to figure out what's going on. So dependency management is about that. It's about finding versions, about selecting versions. That's like the interesting computer sciencey part of the problem. It's also very much a community management problem. We're relying on open source software a lot in the 2010s, in the nearly 2020s. So we often have to ask ourselves, well, how do I know that I got the code I thought I got, that I didn't get some malicious code? How do I publish code that other people can rely on? When I open source something, how do I make sure that it's available to other people? What about a package like UUID? When that dies, what happens? It's no longer being updated. There are security issues. What happens there? There's a lot of interesting sort of social problems involved in distributed dependency management, even more than algorithmic systems. So a little bit about the history of dependency management in Go. Go shipped with this variable called the Go path. You put all your source in the Go path. You build your application. Everything should be in that tree, right? So you had this great tool called GoGet, which would go out to the internet and look at the URL that you provided and download some stuff. A lot of reliance on GitHub, a lot of reliance on sort of hosted proxies. You could get the latest version of everything that was out there, and as long as the language community was small and we were all keeping things up to date all the time, and we were all like building nice backwards compatible code, and we weren't releasing breaking changes without a tag, this worked. But it's like a large social system problem that never happens, right? I remember doing some terrible digging in dependencies of dependencies inside our Go paths at Lightstep to like get submodule this commit into my Go path, make sure that it never changed. It got quite hairy. People started hosting proxy servers like Go package, which would make sure that like if a major version of a library was published, you could always find it. You could go find YAML v2, you could find YAML v1. If there's ever a YAML v3, you won't accidentally upgrade to YAML v3 with breaking changes from v2. This made a big difference for people using GoGet, but if a dependency of YAML v2 changed, you still have this problem, right? There's like, we're getting closer to solving this. We're using convention to do a lot of this stuff. Eventually, people started thinking about things like, what about node modules? In JavaScript, people just download all their source code and they package it all together and they never lose it because it's checked in, right? So we started doing that. We got the vendor directory. This is what we use at Lightstep now. We use tools to manage our vendor directory, but we download all our source code, we bundle it right next to our application code, and we update it when it makes sense to update. There's a sort of resolution strategy that Go started supporting in 1.6 that made this all kind of standardized and made it possible to build tools on top of. That was really helpful. So just put everything in vendor. Everything will work forever, right? The graph traversal problem still exists for us, but at least our source is stable. So we started as a community building tools on top of the vendor directory, third-party tools like Glide or GoDep that I imagine some people in the room are familiar with would manage your vendor directory. And they would include a manifest that would let you describe what your dependencies were. And they would output a lock file that would keep your commit hashes and your source verification hashes in one place. You would know if your code changed or not. And when you wanted to run updates, it would run an algorithm to find out, well, what new things do I need to download? How do I solve that graph merging problem that we looked at a couple of slides back? So finding that set of versions that you need to update is called version selection. You need to basically derive your dependency graph, right? You need to recurse from your binary through all of your dependencies, through all of their dependencies, and accumulate what you need along the way. If you're using package management systems like Maven or Dep or Rust's cargo system, right? You look at each of these packages, they have descriptions of their dependencies, you accumulate their dependencies, you accumulate their constraints, like I can't work with versions newer than X, and I can't work with versions older than Y. And so you build up this list of constraints, and you build up this list of dependencies, and then you try to find a set of dependencies that can satisfy all those constraints. This is generally called version sat, right? Satisfiability. Can I satisfy these constraints with some set of packages and versions? RSC has a great blog post about this algorithm. or rather this problem and why it is an NP-complete problem. There are a lot of heuristic approaches to various forms of the SAT problem, but all of the SAT problems are NP-complete. There's no getting around that. If you have range constraints both above and below, and you have like sort of any set like this, you're going to have an NP-complete problem that you have to solve. And so sometimes your computer will, light on fire while you're trying to download all of your dependencies and verify that they're going to work for you. So GoMod uses a very different kind of algorithm, which is called minimal version selection, or MVS. Now, this breaks a lot of sort of traditional assumptions of dependency management systems. For one thing, it requires that major versions of libraries be different packages from each other. So like that YAML thing that we talked about with gopackage.in, YAML and YAML v2 are different packages. You can, in fact, import them both into the same build. That is a requirement for this algorithm to really work correctly. Certain kinds of constraints, especially exclusions, do not download this version, are only respected if they're from the main module, my binary that I'm building. I can have a list of exclusions. Don't use version X of package Y. But any modules that I import, those exclusions are ignored. We'll get to why that's sort of necessary in a second. And requirements can specify only, and this is why the algorithm is called what it is, the minimal version of the package that they're compatible with. They can say, I require package v 2.1.1, but they can't say greater than 2.1.1 and less than 2.3.0, because I know there's some problem with 2.3.0, right? That constraint is not allowed under this algorithm. So we'll talk about like what that imposes on you as like a library author, for example. But these sort of assumptions are very different from like what DEP uses or what Maven uses to resolve dependency constraints. So why do these things? Because they seem a little kind of iffy. Because version selection becomes a linear time algorithm under those assumptions. You just traverse the graph, you build up a list of all the versions that everything says it works with, and you eliminate duplicates by keeping the newest version under the dupes list. That's it. It's really that. It's that fast. It's like, it's great, but it requires all of those sort of assumptions. The other thing that it enables that are available in some languages and not others, and traditionally not in Go, because Go only allows one package of the same name to exist in a build, is the sort of broken diamond dependency, right? One of my dependencies imports YAML. Another one requires YAML v2. If those are different packages, I can actually import both. I can still build. I'm not broken because some library I depended on updated, and now I've got to go do a bunch of work. So it enables this sort of broken diamond dependency case, which is really useful when you rely on a lot of software that changes a lot of the time, right? You can get updates flowing a little bit more quickly. So we'll talk a little bit about the actual tool and a lot of the good things that are coming for people who will start to use GoMod. So GoMod is part of like the Go tool as of Go 1.1.1 or 1.11. And it's opt-in by default in 1.11, but it's really quite simple to set up. You just GoMod init, you get a module file that's based on resolving the dependency graph for the first time or converting from an existing dependency system. The Go team has done a really nice job of building conversion tools for most of the popular dependency management systems. You can just add an import statement while programming. You don't go do something in some other window and come back and are able to program. You can add an import statement. The next time you build, the next time you test, the module system will automatically update your dependencies, pull in new things into either your vendor directory or a module cache, depending on how you have things configured. But if you really need a specific version, that's always available to you using Go Get. So one of the really nice things here is you're just using the traditional Go tooling that you're kind of used to. You go build, you go test. Most of the time, you don't have to do too much, and you don't have to manipulate some file. But that file exists. It's really nice to read. This is Noah's GoMod file from his talk. I went and took a look while he was talking, and it's a great example because it's got a lot of stuff in it, but you can see how short it is. There's something like 20 dependencies in here, but it all fits on one screen. You declare your module, and you say what you require and what versions you require. A machine can write this file for you, but you can also go modify it yourself when you need to. And you can specify replacement directives. In this case, they want to rely on a local version of the protobuf generator code as opposed to the sort of hosted version. So they have a local, source version of that. That allows them to rely on that code without changing their actual programming code, right? It lets you say, use this instead of what you would normally use. Don't change my code. This can be very helpful in cases like we rely on a cache module at Lightstep that's no longer maintained, so we have our own fork of it. We can use a replace directive here to say, actually, I want to use this code, but I don't want to go update every file that uses the cache package. It's a really nice sort of ergonomic thing. So I really love how straightforward this file is. This is a sort of like core Go thing, right? There aren't that many choices you can make, so there aren't that many ways that this file could look. There aren't that many things you need to understand. It's something I think is a real home run. Some other stuff. With GoMod, you don't have to put Go code in the Go path. The Go path still exists, but you don't have to put your code there. You put your code wherever you want. The module cache will handle downloading things and keeping them for you. It's a little bit like your M2 Maven cache that you may remember from your Java programming days. So that gives me the willies a little bit, but you can still use vendor if you want. If you configure GoMod to use a vendor directory using this command, GoMod vendor, you can instead cache all your dependencies still in a vendor directory within your repository. So there's a lot of useful things here. That's great for CI. That helps you solve the npm left pad problem where somebody deletes their package in a fit of pique and everything goes away. GoMod will never fetch newer things than your dependencies specify. I think this is a really great safety feature. You write constraints that say, I can support 2.1.1. As long as all of your packages are 2.1.1 or lower, you will never get 2.1.2 unless you explicitly ask for it. So people can't, well, people can, I suppose, but this reduces the incidence of people slipping like Bitcoin miners into programs that you might install as a dependency, or all things that I see my JavaScript colleagues at Lightstep going through. Somebody posted in a Slack channel, oh, guess what? One of our deps has a critical security release. Let's be really careful. So I think that this is a great it's a light protection. It's not real protection, but it's a little bit nice. And it gives you a lot of control over what happens. Updating a dep is pretty straightforward. And I'll say it again, MVS is really, really, really fast. When I was playing around with modules for the first time, I was relatively astonished from a clean install. No require file, or I should say, basically, I deleted the go package.toml for our dep usage, ran that under a time constraint. I deleted the vendor directory again and redid it with mod, and it's much faster. So if speed of this kind of thing is a pain point for you, I think this is something that's really worth checking out and at least playing around with in 1.11. Migration from other dependency managers is easy. If you have a setup, it's easy to get going and play. And you don't have to wait for the rest of the ecosystem to all support mod. There's a lot of ways for mod to use libraries that don't use module specifications. We'll talk about the flip side of that in a second, but as a binary builder, it's really nice. You can still just pin commits using these kind of pseudo version declarations that say I'm v000. So the other parts of GoMod. If you're a library author, there's some pain right now, for sure. For one thing, you need to start doing this for major releases. You need to start putting your major version in your package path. Your users need to start putting the major version in their import paths. If you're more than V1, V2 or higher, this stuff starts to show up. It's a little ugly, but I think some of the payoff is worth it, like never getting breaking changes by accident. But I think that this is going to lead to slower adoption of major versions across the ecosystem as they release. I think it's likely to keep old code hanging around for a while. That's not so great. And if you want to support, as a library author, both Go modules and Go code before 1.9.7, it's kind of painful. I think Tim has seen some instances of that. As I was looking at the Gophers repo, there's a lot of stuff in there. Oh, remove the module deck. It doesn't work for any of our older Go users. So it's very new. It needs some time to bake, and supporting older Go code as a library author can be kind of painful. There's guidance out there from the Go team on the Go wiki, but if you're an open source library author, people depend on your code. It's worth being cautious and measured about how you think about adopting this stuff. There's lots of CLI tools that do not work with module-aware development yet. There's a new package that sort of supersedes Go build. This Golang org xtools Go packages is likely to become Go packages in a future language release. It's a module-safe way of importing source and building ASTs and building program representation. So a lot of linters are not really ready yet to use module-aware stuff. This is particularly hard on me. I'm a Vim user. Goland has really great module support, but Vim Go is, it's taking some time. It's an open source. Somewhat overwhelmed, et cetera, et cetera. Local code management. GoMod only does Go stuff. If you've got subdirectories in your projects that are like CGo, C bindings, just protos, you have to do some hackery. If there's repos with multiple modules in them and they both need to be edited at the same time and they kind of rely on each other, there's hackery involved. If you're distributing Go tools along with your binary because you want your teammates to use it, there's hackery involved. You write this funky tools.go file that doesn't do anything and just underline imports all the packages. So there's like tooling and ecosystem stuff here that is, I think, not quite ready for prime time. And this was sort of our conclusion at Lightstep is we're going to wait probably until 1.13 to adopt this stuff. But there's a lot of exciting things on the horizon. August 2019, it's going to be on by default. When you install Go 1.13, don't be surprised if things get a little breaky. GoPath mode will still be available. The tooling will still support GoPath mode, but you're going to want to you're going to have to add some environment flags. And this is the other thing that's coming that I'm very, very, very excited about, which is module proxies. That's infrastructure hosted by big companies with deep pockets to proxy source code to download more quickly. And to have signing, to have a separate verifiable signing log for packages. This is going to be called Notary. When this comes out, we're going to have better answers to how do I know I got the right code? How do I safely use code that I've downloaded over the public internet? We're going to be able to cryptographically verify stuff a little bit better than we currently can. This is going to be really great. This is not directly requiring modules to happen, but as a consequence of kind of establishing an official dependency management system, the Go team also thinks it's important to establish some official tools for verifying the stuff that you get, which is useful for us as a community. Thanks. I'm an engineering manager, which means I have to tell you that I'm hiring people. If you're interested, talk to me after the show. And a few really useful resources if you're interested in dependency management, especially in Go. RSC has some really good blog posts from the last year about SAT solvers, about minimal version selection. And Sam Boyer, the sort of driving force behind DEP, has an awesome post called So You Want to Write a Package Manager that really digs into some of these problems and is really great. Cool. Thank you.
So whenever I go and have like a command line tool alongside my package under, say, a CMD directory / tool name, and I go to actually put a mod file in there so you can build that with its dependencies, you do go modded init, but it doesn't know, if I'm not in GoPath, it doesn't know what to call it, so you get to give it a name. What name should you use there?
So the question was sort of like, I'm just going to repeat to make sure I understand it. When I'm building some command line tool, the package name is main, right? What should I call my module? I think the answer is if you're not sharing it with people, you should call it module A/B. Like it's whatever you want really. It's immaterial. It doesn't really affect your build. It doesn't publish anything into a module cache anywhere, so you can't hurt anybody. You can really call it anything that you want, and it's not going to affect what Go build does. You still have control over everything, all your output, what are your binaries named, etc.
What's your thought on, since you guys trialed it a bit, one of the implicit assumptions with MVS is that everyone in the ecosystem who maintains a library is going to update their dependencies all the time. And so when you're thinking of adopting this inside of the company where you have your own packages you're doing these on, how frequently are you thinking when you get to this point you might be doing regular updates to your packages? Is this something you even thought about at this point when you're doing the evaluation, or?
Yeah. So Tim says one of the underlying assumptions of MVS is that people out in the community are going to keep pushing packages forward, and that that's how we're going to help propagate changes through things. I don't think quite understand the last part of your question. Were you talking about my team's packages or the things we rely on?
I would say like your team's packages, right? Like you're going to have imports internally, and that's going to declare its dependencies. How frequently would you weekly update your dependencies? Would you? Because you have to test it, you have to make sure it's a good thing to do, validate that it's right. But you want to make sure that anything that depends on you will get those transitives with any security fixes or bug fixes that you would want. Since that's a little different than our languages. Other languages, we rely on the range to get us maybe that vulnerability, but also maybe those bug fixes and security fixes that we're not aware of.
Right. This is a good point about how MVS works. Right. You can, if you in things like Node or Maven or whatever, just set a lower bound, you'll get new versions, you'll get updates sort of automatically. Like we do a dep update roughly every week, of some package. I wouldn't say that we do everything every week, but we kind of get some of this without doing too much manual labor. There's something about MVS that kind of says, well, when are you going to update your require statements for your binaries? And I think that this is somewhat of a shortcoming from an ergonomics standpoint, right? The actual command to do this is still just, go get -u. So you can still do those sort of things and pull in updates. I think what I mentioned earlier in the slides about how I think that this is going to overall sort of slow the pace that new code moves through the ecosystem still holds. I think that we'll probably see our code change, but we'll probably run the -u about as often as we currently do.
Did you think about whether running -u whenever you add a new dependency that's direct? I guess the context there is if you pull any transitive dependencies you've never had before, or none of your other dependencies declare versions on, it's not updated, you might get a transitive with a security vulnerability in it when you just added those dependencies. Is that, when you trialed that, was it something that you kind of noted for later stuff when you start to adopt it, or?
Yeah, I have to say we didn't encounter it, but this is a really good point. This is like, if you add a new direct dependency, should you just update all of your dependencies because you don't exactly have control over the graph anymore? And I think it's a useful thing to keep in mind, that when you add a new dependency that has third-party dependencies, you've added a whole set of branches to your dep graph, and it's probably a useful thing to think about, maybe freshing everything up.
So I've never encountered this add a version in your repo, basically copy your code and I don't know, maybe I'm too new to this, but for me it's always been either you do a git tag or something like that. So it seems, I don't know, is that something that existed before that, I don't know, that maybe that's how they were doing with the, version control a long time ago or something, and now they're trying to bring this back. And like you said, it's going to slow down. I feel like it's going to be more than slowing down. I mean, it's going to be a lot of resistance, I feel like. And I'm wondering, what's the long-term game here? When developers are not going to be doing this, there's so many, all the repos that I've interacted with in the past few years, it's all version tag and that's it, right? This thing of adding a new directory for the version is not common. So how do you think that's going to play, from the community side?
I think that, actually, maybe this is worth looking at. this is Lightstep's current gopackage.toml, and I think it's interesting to look at here, like what sort of constraints get pulled down. And a nice thing about dep is it handles basically every kind of like way that you might version code, right? We have things that have version tags that have V's in front of them. We have just V2s, because this is actually fronted by gopackage.in, for example. We have just a branch. This is just the head of a branch. Like this makes me like sweat at night when I look at this. I'm just like, oh God. If somebody does update and it doesn't break, but it's malicious now, what are we gonna do? Right, one really nice thing about this way of approaching things is you can kind of get your code from anywhere. Whereas, Module's way of addressing this, like there's no version tag kind of thing, is to use, you see these things that say v0.0 -datestamp -hash. That's like a commit hash from that system. So mod still has ways of addressing this case where there's no version tag, or where the package maintainer doesn't play into the overall system, right? Which I think is nice and forward-thinking compared to, I always go back to Java because I was a Java developer for a long time. If something wasn't on Maven Central, good luck. You've got to go like find some other repo and download it. So I think mod has some decent answers to this question, right? You can refresh this and get a new version kind of at head if you need to depend on that sort of thing. So I think that the tool has been designed pretty well to say that we don't need the entire language ecosystem to do exactly what we want them to do. It'll be better for everybody if they do, I think is the thinking, but it's not necessary in order to build your software.
Just to call out, you don't technically have to do the version directories if you don't want to.
Tim just said you don't have to do a vendor directory. You don't have
the version, the version, like the V2, V3. I think that was kind of your question around the V2, V3 directories.
Yeah.
That will virtualize that based on tags. You just need to make sure your Go mod file has V2 in the import of the module.
Oh, okay.
And so it uses that Go mod file to go, oh, I need V2. Oh, I'm at V2. Okay, I can use this commit because it has the version there. So you don't have to do that, but that is one way to accomplish that.
Okay, that makes sense.
So does it mean that you don't need a vendor directory for this?
You can build using Go modules without a vendor directory. Go will put the downloaded modules in a module cache with a established path. So it does look a lot like a Maven cache, right? It's always in the same place. The code is like tagged, so these versions have hashes, and you know where things are.
Because anyway, every time it has to fetch from the web, right? Is that a problem?
It only needs to fetch from the web to download, just like you would if you were doing a vendor directory. Your module cache is on your local machine. As long as you don't need an update, you don't need an internet.
You don't need it. Secondly, if I have both, what happens?
Sorry?
Like, if I have both, more dep as well as Go mod, what happens? Which one works?
Oh, if you have both.
Both.
If you're manipulating the vendor directory with both, this isn't something that I've tried. But if you run mod in module mode and in module cache mode and you run dep with toml, I hope that they don't download incompatible versions. They won't necessarily find the same answer. So you won't necessarily have the same code in both cases. I heard a question, where's the module cache? It's on Macs like home/.local/something. Yeah.
Okay.
Oh, sorry.
I believe it's still under the Go path.
Tim believes it's still under the Go path. I'm not going to try to verify
I think the default. I think it uses the default if you don't have the Go path set. Cool. So home Go, as it normally would.
How would you recommend this with CI? Because caching things works different in CI versus on your desktop.
Totally. When we talked about this, we're planning to use the vendor directory. I think initially there was some talk about not supporting the vendor directory anymore. There were a lot of emails that flew through the Go email list, Slack channels, and et cetera. Vendor support was retained with all the build tools. I think CI is like the killer use case for that, right? Just bundle everything up, check it out on your CI machine, and build. Right? So we're planning to continue to use the vendor directory.
And so just to call out, there's there is a separate flag you have to pass to Go build to get it to use the vendor directory. So by default, if you have module mode enabled, it will not use the vendor directory. So it's like mod, I think it's like -mod equals vendor. And then Go build will use the vendor directory in that case. So you do have to opt back into it, just to call that out.
What are the problems you see with the CI, with the, like, because I have Go enabled and I let the CI just download and build. Like.
I work in a place where actually hitting all these things and downloading these things is actually a performance problem.
Oh yeah, totally. It is for us too. You don't, even if you have a modulo cache, you don't have to download these all every time. I think this is also part of the overall kind of Go debate. Should you check in the vendor directory or not, right? We check in the vendor directory for exactly this reason, so that there's only one place to get my sort of archive of all the source code that I need to build my binary, right? In path with my code, right? There's like my code at the top, vendor / all of my dependencies. I think that I would recommend, I mean, you can still have a vendor directory that mod supports, as long as you need to modify how you use the tooling a little bit in order for that to happen. But you don't, that means that you can download one bundle.
It's the downloading, that's the, because isn't that what Notary and like what they're going to be solving?
Well, yeah, there can be faster mirrors, but that doesn't solve the problem of if I just don't have an internet connection for whatever reason, shipping archives around on disks. There's lots of other cases where you might, but Notary is designed to help you verify that the code you downloaded is the code you thought you were downloading.
I was going to add that, like, if you have like internal repositories that are public and your CIs don't have access for like authentication reasons or something, that's another good reason for the vendor directory.
I think when you were talking about Notary, but I'd go for Palooza. This guy made a talk on. It was not Notary. It was this other project. Can't remember, but it was like creating repos, so you can actually create your package repo, like get that in, like a mirror, but behind the firewall. Then you can.
I think you're talking about Athens.
Yeah,
Athens.
I think so
That's
too.
it.
Yeah, Athens is a really interesting project that I recommend people check out. Athens is very interesting, especially because it doesn't really allow for unpublishing code, which is an interesting problem and solution and community question in source in general, right? Who owns the code? If you've published it ever on the internet, should it always be? So I think Athens is a very interesting project and is probably going to also be a useful adjunct to all kinds of dependency management in Go.
Would it make sense to have some sort of a Go mod update so that it kind of prints or asks in a manner, these are the updates that are possible for.
Or are you talking about like an interactive mode kind of?
Yeah, interactive.
Yeah. Correct me if I'm wrong, Tim, but I'm pretty sure go-get-u has a dry run mode that you can do this stuff with, right? You can do go-get-u. I don't know what the dry run flag is, but if you give the dry run flag, it won't actually change things. You'll get a list of what you would have gotten. Cool. All right. Thanks, everyone.